Hello everyone. Today I'm going to show you how to design a screw in SolidWorks. There are many ways to design a screw, but in this video I'll demonstrate how to create one based on standards. This method might be a bit time-consuming, but it's an excellent practice for learning different features and honing your problem-solving skills. I'll also create another video in the future to show you a faster and simpler way to design a screw. Let's get started. First of all, let's look at the dimensions of the screw. For example, we are going to design a Hexagon socket head cap screw M20. We'll need to know the thread length, diameter, chamfer size, pitch, and other dimensions of the screw. How do we find a reference for these numbers? Thanks to organizations like ISO and DIN for setting standards. The best way to get these dimensions is by using pre-published standards. I searched and used AI assistance to find the appropriate standard for my design, and the results showed that the international standard ISO 4762 is suitable for designing hexagon socket head cap screws. I have already purchased this standard, and if you want to use it in your projects, I recommend buying it as well. Additionally, there's a great book by Ulrich Fischer called Mechanical and Metal Trades Handbook. It's a very useful and handy resource for mechanical engineers, and I strongly suggest having it in your library. For the purpose of this video, I have summarized the dimensions into this drawing. Please be aware that some values have a range, and I have selected values within the acceptable range for the sake of this tutorial. First of all, I open SolidWorks, start a new part, and draw a sketch on the top plane based on the summarized drawing and the mentioned standard. This sketch will be used later in the Revolve feature. After drawing the overall shape, I use the Smart Dimension tool to provide all the required dimensions until the sketch is fully defined. Now, a 2 mm chamfer is added to the head of the screw. After drawing the sketch and assigning dimensions, I apply the revolve feature. As you can see, a minor edit is also applied after the revolve. Now we have the body of the screw, but our screw doesn't have any threads. This is because the pitch and profile of the threads aren't provided in ISO 4762 directly. So, how do we get this data? If we look deeper into ISO 4762, in Section 2, Normative References, there are other standards given as references to complete our job. Here, ISO 261 provides data for ISO general purpose metric screw threads. Let's take a look at that reference. According to ISO 2261, for an M20 coarse thread, the pitch is 2.5 millimeters. By means of ISO 261, we found the pitch value of the M20 threads. But what about the shape profile of the thread? Just like before, if we look at Section 2, Normative References, we can see that ISO 68-1 is referenced for ISO general purpose screw threads. So it seems we have to use another reference to continue designing our screw. For creating threads, we need to use the Helix and Spiral tool. When I click on the Helix and Spiral tool, it asks me to specify a sketch with a circle for the cross-section of the helix, or to select a plane to draw that sketch. I select this face, convert the outer circle of the screw, and then exit the sketch environment. I specify the height and pitch of the spiral to 52 millimeters and 2.5 millimeters respectively, set its direction, and then click the OK button. As you can see, the starting point of the spiral is on the top plane, so I create a sketch on the top plane. This sketch will contain the profile of the cutting section for creating the thread based on ISO 68-1. The dimensions are based on only two parameters, P for pitch and H, which is a function of P and calculated as H equals frac squirt 32 times P. So I want to use global variables for these two parameters. This way, I can simply type P4 and SolidWorks will do the calculations automatically. There are other benefits to using global variables here, such as the ease of changing the pitch if needed and reducing the chance of making mistakes. After drawing the cutting section, I use the swept cut feature. The swept cut feature in SolidWorks allows you to create a cut by moving a profile, the cutting section, along a predefined path, the helix in this case. This tool is essential for creating complex shapes like threads on a screw. This tool needs two sketches, one for the cutting section and another for the path that the cutting section will move along. I use the drawn sketch and the helix for this purpose. As you can see, the sweep cut encountered an error. The reason for this error is the self-interaction of the cutting section. Pay attention to the length of the cutting section, which is equal to the pitch of the helix. To resolve this, I trimmed a bit of the excess part of the cutting profile. Everything seems to be okay, but I think the end of the thread needs a final touch. To fix it, I create a sketch on this face, convert the face to a sketch, and then use an extrude cut to shape the profile and make the thread look more realistic. Voila! We have successfully designed a hexagon socket head cap screw M20 with a coarse thread based on ISO 4762, 261, and 68-1 standards. It took a lot of effort. However, it takes much dedication and perseverance to master these skills. This exercise is an excellent opportunity to learn how to use standards alongside enhancing your 3D designing skills. Thank you for taking the time to watch this video. If you found it helpful or enjoyable, please consider giving it a like, leaving a comment with your thoughts or questions, and subscribing to the channel for more content like this.